Thank you. So, once again, welcome to my YouTube channel. I'm going to show you today, we are going to cover this topic. It's called the kth smallest element in a binary search tree, and this is a Leetcode 230, and basically the question goes as: given the root of a binary tree and an integer k, return the kth smallest value, one indexed, of the values of the nodes in the tree. So basically, you see here we have a tree, our root is 3, and we have 1, we have 2, we have 3. So if you check, for example, if you would like to order these, the elements of the tree, we have basically 1 is the first element, that is the lowest with the lowest value. This is the second element with the lowest value. This is the third element with the lowest value. This is the last element with the lowest value. And here they're asking us to look for k, where k basically for the kth element. So they gave us k, which is equal to 1. So we need to look for the first element that has the lowest value. So there are a lot of approaches you can use here. You can do, for example, you just traverse through all the elements of the tree, and then you put them in an array. Once you put them in an array, then you sort the array and you just look at k minus 1, at an index of k minus 1. That's a very easy approach, but as you can understand, we use n log of n because we are going to because we need to like sort the array. You can also do something like you do an in order traversal, I think so, yeah. Then once you do the in order traversal, basically it will first go to the leftmost element, then get it, which will be the lowest, then it goes to the right of the leftmost element, which in our case to start with 1. Then once it puts 1 in an array, it goes to 2. Once you put 2 in an array, it goes 2 in an array, goes to 3, like that. So if you do that one, if you put that one if you do that one, then it's easy. Like you can see also, it will be easy. Then the array will be sorted for you, and then you can by default just give it k. You say this is k of, like, no, you return the array but looking at the kth index. That's the second approach, which is a bit better compared to the first one, but also uses memory of O of n. Now what we need to do is to use, if we can find like a solution which is, let's say, which is efficient to the point where it doesn't use memory of O of n, and it uses and it doesn't use memory of O of n, and it also uses it passes through each element once. So this is these are the test cases. You can see we have different test cases, and this is my solution. So in my solution, this is what we do. Oh, sorry, some battery, whatever. Then this is what we do, or what's there is, like, you see we have this initialization. So I want to have 2 variables, the one which we hold our count, so to know, like, since we are given k which is equal to 1, so I know, like, this is the first element that has the lowest value or something like that. Then we need the result. This is the one to hold the result, and we put it in an init, because I've seen that when you put them as like let's say public elements, no, not public elements. Once you put it as public variables of this method, of this class, then they can be used. They will be reused once they get the next test case, which will fail. So now what I'm going to do is I initiate this DFS function which is inside my kth smallest. So what I do is, first of all, I have to check if the node that I pass into my DFS, if the node is like not present, then you just return. Then I first go to the leftmost element of the node. So this will call, this is a recursive call until it gets to the leftmost element. Then it comes to it every node that after we return the kth node, like the leftmost element, which is the minimum, it's going to increment my count. So to know that this was the first one, then the second one, the third one, something like that. Now this, after this one, you can see we have the counter, and no, not the counter, the count. Our count, in case the count is equal to k, which we are provided, then assign our result to this variable, and we don't want to progress because we have already got what we wanted. And then once we get that, you see if we don't get this, then we also traverse the right elements, so the right minimum elements. Now after that, we initialize our function so that the recursive functions can start. And what we do is we say DFS loot, we pass it the first element of the loot, then we return our result. And once you check, if you check my solution works for it should be working for the test cases, and once you submit, it should be able to work too. Nice, thank you.